Assalamu alaikum. Eid Mubarak. I hope all of you are well. Students, today is the first class after your Eid vacation. I hope all of you enjoyed your Eid vacation and completed your all homeworks. Today I am with you, Rizwana Mukhtar, lecturer, Department of Physics, Milestone College. Students, you have already completed your chapter 3, which is force. And in my today's class, I am going to solve two creative questions from this chapter. I hope this class will help you for your better study. So, let's start our today's class. Students, our first creative question is from Kumilabo 2015. The question is, a truck is moving with a velocity of 20 meter per second of mass 700 kg, collides with the truck of mass 1300 kg when it is raced. And two trucks are united together and the combination is moving in forward direction. That means there was two trucks, one was moving with a velocity of 20 meter per second and another truck was in at rest position. And after some time, these moving trucks hit the rest track, and as a result, these two trucks start to move combinedly in a forward direction. So here the question C is, find the combined velocity of the two trucks. To solve this question, here the given informations are mass of the first truck. If we denote the mass of the first truck by M1, then the value of M1 is, consider it as 700 kg. Now, mass of the second truck. Mass of the second truck is 1300 kg. That means the value of M2 is equal to 1300 kg. Now, initial velocity of the first truck. Initial velocity of the first truck is 20 meter per second. So, we can write that U1. You know that initial velocity is denoted by U. So, the value of U1 is 20 meter per second. Now, initial velocity of the second truck. As you can see that the second truck is in rest. That means the initial velocity of the second truck, that is the value of U2 is 0. Now, we have to calculate the combined velocity. That means the value of V is equal to what? So, we know that to calculate the combined velocity, equation is m1u1 plus m2u2 is equal to m1 plus m2 into v. That is, v is equal to m1u1 plus m2u2 divided by m1 plus m2. Now we know all the informations, that is the value of m1 is 700, u1 is 20 plus the value of m2 is 1300 and u2 is 0 divided by 700 plus 1300. As a result, calculating it, you will get the result of combined velocity is 7 meter per second. This is the answer of your question C. Question D. The question is, this stem is supporting Newton's third law of motion. Explain mathematically. Students, to solve this question, the given informations, we have already got that the mass of the first truck is 700, mass of the second truck is 1300 kg, initial velocity of the first truck is 20 meter per second and initial velocity of second truck is 0 meter per second. And from C, we got the combined velocity, that is the value of V is 7 meter per second. Now in the question you can see that the question says that this stem is supporting Newton's third law of motion. You know that Newton's third law of motion is for every action there is same and opposite reaction. That means if any object applied a force on second object, then the second object will also apply the same and opposite force. That means according to Newton's third law, we can write that from Newton's third law, we can write that F1 is equal to minus F2. Now from this equation we got another equation which is known as the conservation law of momentum, and the equation is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So students, here you can see that if we can prove that the total momentum, that is the total momentum before collision and the total momentum after collision is same, then we can say that this stem is supporting Newton's third law of motion. So firstly we are going to calculate that the total momentum before collision. Now we can say that total momentum before collision if we denote it by P1, then we can say that P1 is equal to M1 U1 plus M2 U2. Now the value of M1 is 700, U1 is 20 plus the value of M2 is 1300 and the value of U2 is 0. So we will get the value of total momentum before collision is 1400 kg meter per second. So total momentum after collision, if we denote it by P2, then we can write that P2 is equal to M1 V1 plus M2 V2. As after collision the two trucks starts to move combinedly, that we can write that this equation is M1 plus M2 into V. Now put the given informations. The value of M1 is 700 plus the value of M2 is 1300 and the value of V. From C we got the value of V is 7. So we can write that into 7. And after calculating it, you will get the value of total momentum after collision is also 1400 kg meter per second. So students, you can see that the total momentum before collision and the value of total momentum after collision is same. That means this stem is supporting the Newton's third law of motion. Students, our second creative question is that the height of the space station from the Earth's surface is 400 km. An object is brought to the space station according to the figure. So here you can see that in the figure, object firstly kept on the Earth's surface, and after that this object which mass is 10 kg is brought to the point B. That means at the space station which is 400 km away from the Earth's surface. Now the question C is find out the value of acceleration due to gravity at point A. That means we have to calculate the value of acceleration due to gravity when the object is on the Earth's surface. So, the given informations are here. Mass of the Earth. You know that we denote the mass of the Earth by capital M, and the value of capital M is given here 5.98 into 10 to the power 24 kg. Radius of the Earth. The value of R is 6.37 into 10 to the power 3 kilometer. So, if you convert it into meter, then we will get the value is 6.37 into 10 to the power 6 meter. Now, gravitational constant, that is the value of capital G, is given here 6.673 into 10 to the power minus 11 Newton meter square per kg square. And we have to calculate the acceleration due to gravity at point A. That means the value of Ga is equal to what? And you know that we know G is equal to Gm by R square, as we are calculating the acceleration due to gravity at point A. So, I denote it by Ga. You can see that the value of G is 6.673 into 10 to the power minus 11. The value of M is 5.98 into 10 to the power 24, and the value of R 6.37 into 10 to the power 6 whole square. And after calculating it, you will get the value of acceleration due to gravity at point A is 9.83 meter per second square. And this is the answer of question C. Our question D is there be any difference of the weight of that object at point A and B? That means when the object is at point A, at that point we have to calculate the weight of that object, and as well as when the object is brought to the space station, at that point we have to calculate the weight. And you know that weight is totally depends on the acceleration due to gravity. So, to calculate the weight for point A and B, we have to know the value of acceleration due to gravity at point A and point B. And in question C, we have already calculated the value of acceleration due to gravity at point A. So, to calculate the weight of that object for point A and B, firstly we have to calculate the acceleration due to gravity at point B. Then we can easily calculate the weight at point A and point B. So, for question D, the given informations, to solve the question D, the given informations which we have already discussed in question C are that the mass of the Earth, radius of the Earth, and gravitational constant is already given in the step. And from C, we got the value of acceleration due to gravity at point A is 9.83 meter per second square. Acceleration due to gravity at point B, that is GB, is equal to what? To calculate the acceleration due to gravity at point B, we have to know the value of height, that is the distance of the space station from the Earth's surface, and the value is given here 400 kilometer. So we can write that the height of the space station, if we denote it by h, then the value of h is given here 400 kilometer. Now we can write it at 400 into 10 to the power 3 meter. So students, we know that G is equal to Gm by r square. But as we are calculating the acceleration due to gravity at point B, that is 8 meter away from the earth's surface, so we can write that equation Gm, instead of r we have to write that r plus h whole square. Now put the given informations. The value of G is 6.673 into 10 inverse 11. The value of M is 5.98 into 10 to the power 24 divided by the value of R, that is radius of the earth is 6.37 into 10 to the power 6 meter, plus the value of height is 400 into 10 to the power 3 meter, that is whole square. And you will get the value of acceleration due to gravity at point B is 8.27 meter per second square. So students, here now we know that the value of GA is 9.83 and the value of GP is 8.27. We can write that weight at point A, if we denote it, weight of point A, if we denote it by WA, then we can write that WA is equal to mGA. Now the value of M, that is the mass of the object, is given here 10 kg. So we can write that 10 into the value of GA is 9.83. So we will got the value of weight of the object at point A is 98.3 Newton. In the same way, we can calculate the weight of the object at point B. So if we denote it by WB, then we can write W is equal to mgb. As the value of mass is same, so the value of AM is 10 and now the value of GB is 8.27. So weight will be 2.7 Newton. Friends, here you can see that the weight of the object at point A is 98.3 Newton and at point B is 82.7 Newton. That means we can say that whenever we brought an object outside the Earth's surface, then the weight of that object will decrease as the acceleration due to gravity is decreasing. And this is the answer of your question D. That means there is a difference between the weight at point A and point B. That's all for today. Thank you for your patience hearing.